PE file structure. Portable executable (PE) file format is a file format for executables .x and dynamic link library .dll used in 32-bit and 64-bit versions of the Windows operating system. It encapsulates the information for the Windows OS loader to manage the wrapped executable code. This includes dynamic library references for linking, import table, API export, TLS, and resource management data. Overview of portable executable file .x. Structure of portable executable (PE) file format. The given below image is the full structure of the portable executable file structure. Full structure of portable executable file. DOS header. It occupies the first 64 bytes of the PE file. In this article, we'll not examine all bytes, we just focus on only A magic and AIFA new of the PE file. You can see the ASCII column, it shows MZ, which means magic number. All executable files have a magic number with the value hexadecimal 5A4D, it mentioned at the beginning of the PE file. Another field is AIFA new. It has a 4-byte offset. It is the pointer to the PE header. In the given below image, I explained the DOS header with mspaint.x file using the PE bear tool. DOS header of mspaint.x. DOS stub. If we run 64-bit PE inside DOS, the stub will execute, and we get this message, this program cannot run in DOS mode. This message is used to find whether this program is compatible or not compatible with Windows. You can see this in the given below image. DOS stub header of mspaint.x. PE header. The AIFA new field will give the offset of the PE header. It contains FILESIGNATURE, IMGFILEHEADER, and IMGOPTIONALHEADER. FILESIGNATURE, the first 4 bytes include the signatures. For example, in our sample program mspaint.x program shows the first 4 bytes 00004550 and the signature value is hexadecimal 5045. In the ASCII column, it shows the string PE. So, we confirm it is a portable executable. PE header mspaint.x. IMGFILEHEADER. It occupies 20 bytes of the PE file and it contains the basic information about the file layout such as machine, number of sections, time date stamp, pointer to symbol table, number of symbols, size of optional header, and characteristics. IMG_file_header of mspaint.x. IMGOPTIONALHEADER. It's not optional, it's an important one. Because it contains critical information about the PE file. IMG_optional_header of mspaint.x. Some of the important fields are listed below. I, magic, it defines whether an executable is 32-bit or 64-bit. If the value is hexadecimal 10B, it is a 32-bit application, and if the value is hexadecimal 20B, it is a 64-bit application. E, entry point, it's the execution of the first instruction. E, base of code and base of data, it holds the relative virtual address, RVA, of the beginning of the code and data section, respectively. IV, image base, default base address 0 by 400,000 for applications and 0 by 10 million for dynamic link library. V, size of image, it indicates memory size occupied by PE in runtime. V, section alignment, it indicates the alignment of the section of PE in the memory. V, file alignment, it indicates the file alignment in PE. V, subsystem, this field is used to identify the target subsystem for an executable file. Data directory. It indicates where to find the other important components of the executable file. Mostly, the PE file format defines 16 possible data structures. You can see the data directory in the given below image. Data directory of mspaint.x. Some of the important data directories. I, export directory, it contains a table of exported functions. E, important directory, it contains a table of imported functions. E, resource directory, it contains a table of resources such as images embedded in the PE, icon, etc. IV, import address table, which stores the runtime address of the imported functions. IMGSECTIONHEADER. It contains information related to the various sections available in this executable file. You can see this in the given below image. img_section_header of mspaint.x. Some of the important fields are given below. I. Virtual size. It indicates the size of the section in memory. E. Virtual address. It is the offset from the base address where the section should start. For example, if the base address is 40,000 and the virtual address is 200, then the section starts at 40,200. E. Size of row date. It specifies the size of the section in the pay file. IV. Pointer to row data. It uses offset to find where the section starts in the pay file. V. Characteristics. It denoted by flags, R readable, RW readable and writable, RWX readable, writable and executable, to tell about the memory access rights for the section in memory. Sections. You can see the sections of the pay file in the given below image. Sections of mspaint.x. I. Text section. This text section contains the program's instructions. E. Data section. This data section is generally used for writable data with some initialized non-zero content. E. R data section. This R data section contains read-only data in an executable file. IV. E data section. This E data section contains an export directory, descriptors, and handles. V. RSRC section. This RSRC section contains resources for an executable file such as icons, images, etc. V. Debug section. This debug section contains